So last month, I was reviewing a client's AWS bill, and they were paying over $12,000 a month just for data transfer to S3 from their VPC. $12,000. And the fix took exactly 3 minutes and cost them $0 per month going forward.
Wait, $0? How is that even possible? What were they doing wrong?
They had hundreds of EC2 instances making API calls to S3, and all that traffic was routing through a NAT gateway. NAT gateway charges you about 4.5 cents per gigabyte processed, plus there's an hourly charge of about 4.5 cents per hour. They were moving around 260 terabytes a month to S3, so the data processing alone was over $11,000, plus the hourly charges pushed them past $12,000.
Oh wow, so the NAT gateway was basically acting as a toll booth for all their S3 traffic?
Exactly right. And the solution was a gateway endpoint for S3, which has no hourly charge and no per gigabyte charge. Welcome to Cloudcast, everyone. I'm Network Ninja, and today we're diving deep into VPC endpoints with my co-host student. We're going to break down the difference between gateway and interface endpoints, when to use each, and most importantly, the real performance and cost implications.
I'm excited for this one because I've honestly been confused about VPC endpoints for a while. I know they let you connect to AWS services privately, but I don't really understand why there are two types or when I'd pick one over the other.
Perfect starting point. Let's establish what problem VPC endpoints solve. When you have an EC2 instance in a private subnet and it needs to talk to S3 or DynamoDB or any AWS service, by default that traffic has to leave your VPC, traverse the public internet, and come back into AWS's network.
So even though both my EC2 instance and S3 are in AWS, the traffic is going out to the internet and coming back?
Exactly. And to do that from a private subnet, you need either a NAT gateway or a NAT instance. That's where the cost comes in, plus you're adding latency and potential security exposure. VPC endpoints create a private pathway that keeps traffic entirely within the AWS network.
Okay, so VPC endpoints are like building a private tunnel directly to the AWS service, instead of going through the public entrance. But why two types?
Great question, and this is where it gets interesting. Gateway endpoints came first, introduced back in 2015, and they only support two services, S3 and DynamoDB. Interface endpoints, powered by AWS Private Link, came later and support over 100 AWS services plus third-party services. The architecture is fundamentally different.
So gateway endpoints are older and more limited. Why would I ever use them then?
Cost. Gateway endpoints are completely free. No hourly charge, no data processing charge. Interface endpoints cost about 1 cent per hour per availability zone in US East 1, though pricing varies by region. Data processing is about 1 cent per gigabyte for the first petabyte, with tiered pricing that decreases for higher volumes. Always check current pricing for your specific region. That adds up fast.
Okay, so for S3 and DynamoDB specifically, gateway endpoints are the obvious choice because they're free?
Usually yes, but there's a catch. Gateway endpoints work by adding route table entries. When you create one, AWS adds a prefix list route to your route tables pointing S3 or DynamoDB traffic to the endpoint. This only works for traffic originating from within your VPC.
What do you mean only from within the VPC? Where else would traffic come from?
On-premises networks connected via VPN or Direct Connect. Gateway endpoints cannot be directly accessed from outside the VPC. If you have a hybrid architecture and your on-premises servers need private access to S3, you have two options. You could set up an EC2 proxy instance within your VPC that uses the gateway endpoint, or you could use an interface endpoint for S3, which provides direct access without needing a proxy.
Wait, S3 supports interface endpoints too? I thought gateway endpoints were the only option for S3.
Great catch. S3 is actually unique in that it supports both gateway and interface endpoints. Gateway is free and perfect for most VPC internal use cases. But interface endpoints for S3 are needed when you want direct on-premises access, when you need security group controls, or when you're accessing S3 from a different region's VPC via inter-region peering.
Oh, that's a huge distinction. So gateway endpoints are VPC only, but interface endpoints can be reached from connected networks?
Exactly. Interface endpoints create actual elastic network interfaces, ENIs, in your subnets with private IP addresses. Those IPs are routable from anywhere that can reach your VPC, including on-premises networks. Let me give you an analogy. Think of gateway endpoints like a private door in your office building that only employees inside the building can use. Interface endpoints are like installing a new reception desk with its own address that anyone with the right credentials can visit.
That makes sense. The gateway is internal only. The interface has its own addressable location. But you mentioned the interface endpoint creates any's and subnets. Does that mean I need one per availability zone?
Yes, and this is important for both cost and high availability. When you create an interface endpoint, you select which subnets to deploy it in. AWS creates an any in each subnet with a private IP from that subnet's CIDR range. For high availability, you should deploy in at least 2 ASs, which means 2 any's, which means about 2 cents per hour or roughly $14.60 per month just for the endpoint, assuming a 730-hour month.
And then there's the data processing charge on top of that?
Right. About 1 cent per gigabyte for most usage levels, with tiered discounts at very high volumes. So if you're processing 100 terabytes through an interface endpoint, that's about $1,000 in data charges. Compare that to a gateway endpoint for S3 where that same 100 terabytes costs zero.
This is making the gateway endpoint look really attractive for S3. Are there any performance differences?
This is where it gets nuanced. Gateway endpoints use AWS's internal network and route table entries, so traffic flows directly to the service. There's no additional hop. Interface endpoints add a hop through the any, which introduces some additional latency. The exact amount varies based on your specific setup, so I'd recommend benchmarking in your own environment if latency is critical to your application.
Even a small amount of latency could matter for some workloads, right?
For most applications, it's negligible. But if you're doing millions of small object requests to S3 per second, even small latency differences compound. I've seen high-frequency trading workloads where they specifically chose gateway endpoints for S3 to minimize every possible bit of latency.
What about throughput? Can one type handle more traffic than the other?
Gateway endpoints don't have a bandwidth limit documented by AWS. They scale automatically. Interface endpoints support up to 10 gigabits per second of bandwidth per availability zone by default, and you can request increases through AWS support if you need more. That 10 gigabits per second limit is independent of the instance types in your subnet since AWS manages those any's separately from your resources.
Let me make sure I understand the decision framework. For S3 and DynamoDB, use gateway endpoints unless I need on-premises access or security group controls, in which case use interface endpoints. For everything else, interface endpoints are the only option.
That's the baseline. But there's one more consideration. Interface endpoints support endpoint policies and security groups. You can restrict which principals can use the endpoint and which actions they can perform. Gateway endpoints support endpoint policies too, but not security groups since there's no any. Also worth noting, interface endpoints support VPC flow logs on their any's, which is great for monitoring and troubleshooting. Gateway endpoints don't have that capability.
So interface endpoints give me more granular security controls and better visibility?
Yes, you can attach a security group to an interface endpoint any and control exactly which source IPs or security groups can send traffic to it. With gateway endpoints, you control access through the endpoint policy and route table associations, but you can't do source IP filtering at the endpoint level.
What's a common mistake people make with VPC endpoints?
The biggest one I see is creating an interface endpoint for S3 when a gateway endpoint would work fine. I've seen teams spend thousands of dollars monthly because someone just clicked through the console without understanding the cost implications. The second mistake is forgetting about DNS prerequisites. Interface endpoints can optionally enable private DNS, which overrides the public DNS for that service to resolve to your endpoint's private IPs. But here's the gotcha. To enable private DNS, your VPC must have both DNS hostnames and DNS resolution enabled. I've seen plenty of deployment failures because those VPC settings weren't configured.
What happens if you don't enable private DNS?
Your applications would need to use the endpoint-specific DNS name, which looks like ABS 123456789 OABHEDEF0US East 1.S3.US East 1.VACE.Amazons.com. Most applications are configured to use the standard service endpoint like S3.US East 1.Amazon.com. If you enable private DNS, that standard name resolves to your endpoint's private IPs automatically.
Can you walk me through a real scenario where I'd set this up?
Sure. Let's say you have a 3-tier application in a VPC with CIDR 10.0.0.0 out of 16. Your application tier in private subnets needs to access S3 for object storage and secrets manager for database credentials. For S3, I'd create a gateway endpoint. In the console, go to VPC, then Endpoints, create endpoint, select S3 as the service, choose gateway type, and select which route tables to associate. AWS adds a route with a destination prefix list pointing to the endpoint. You can find the correct prefix list ID for your region by running AWS EC2 describe prefix lists in the CLI, since these are AWS managed and you shouldn't hardcode them.
And for Secrets Manager?
That requires an interface endpoint since Gateway only supports S3 and DynamoDB. Create another endpoint. Select com.amazonoz.us east1.secrets manager, choose interface type, select your private subnets in at least 2 OSs, attach a security group allowing HTTPS on port 443 from your application security group, and enable private DNS. Remember, your VPC needs DNS hostnames and DNS resolution enabled for that private DNS option to work. Now your applications can call Secrets Manager using the standard endpoint and traffic stays private.
What would that cost monthly?
The Gateway endpoint for S3 is free. The interface endpoint for Secrets Manager with 2 OSs would be about $14.60 per month for the hourly charge, plus about 1 cent per gigabyte of data. Secrets Manager calls are typically small, so data charges would be minimal, maybe a few cents.
Compared to routing through a NAT gateway?
NAT Gateway charges about 4.5 cents per gigabyte plus about 4.5 cents per hour. If you're making lots of API calls, the interface endpoint is often cheaper than NAT Gateway, plus you get the security benefit of private connectivity.
All right, let me summarize what I've learned. Gateway endpoints are free, only work for S3 and DynamoDB, only accessible from within the VPC, and work via route table entries. Interface endpoints cost money, support over 100 services including S3 as an alternative option, are accessible from on-premises via VPN or Direct Connect, create ANIs with private IPs supporting up to 10 gigabits per second per IS, and support security groups and VPC flow logs.
Perfect summary. I'd add 4 key takeaways. First, always use gateway endpoints for S3 and DynamoDB unless you specifically need on-premises access, security group controls, or inter-region peering. Second, calculate your data transfer volumes before choosing between interface endpoints and NAT Gateway. Third, deploy interface endpoints in multiple OSs for high availability, and factor that into your cost calculations. And fourth, always verify current pricing in your region and check your VPC DNS settings before enabling private DNS on interface endpoints.
This has been incredibly helpful. I finally understand why there are 2 types and when to use each.
That's what we're here for. Thanks for joining us on Cloudcast, everyone. Next week we're covering Transit Gateway and how to build hub and spoke network architectures. Until then, keep your packets private and your bills low.